Hi, welcome to this lesson on probability counting principles part 1. Let's have a look at counting without repetition. So, let's have a look at the following example. Brendan plays the lotto and needs to choose from 5 numbers and 1 bonus number. So from 5 numbers and 1 bonus number. So in total he's picking 6 numbers. And the 6 numbers that he is choosing from is from the set A from 1 to 50. So you can imagine a typical lotto card that would have the numbers 1, 2, 3, 4, all the way up to 50. So Brendan needs to choose 1, 2, 3, 4, 5 numbers and a bonus number somewhere here. So 6 numbers in total. How many ways can Brendan choose these 6 numbers? So again, we're not interested if these are the winning numbers or not. We just want to know how many different 6 numbers of the 50 can Brendan choose from. Okay, so if we define the set A1 as the event of choosing the first number, then how many ways can he choose the first number out of the 50? Well, there are 50 different numbers, so he's got 50 different possibilities to choose the first digit. Now notice if Brendan picks that first digit, that's marked on the lotto card. So that number's been used already. So this is why we mean there is counting without repetition, because we can't count that number again in the next set. Okay, because that number's already been chosen. So if we define A2 to be the event of choosing the second number, then since we've chosen the first one, there are only 49 possibilities left for Brendan to choose from. So Brendan picks another one of those 49 numbers left over, and now he's picked 2 out of the 6 that he needs. Similarly, if we keep defining the events A3, 4, 5, and 6 as picking the 3rd, 4th, 5th, and 6th number, then you'll see the pattern that he has one less number to choose from each time, because he's taking that number, shading it in on the lotto card, and now it's been chosen. It can't be chosen again, okay, because he needs to pick 6 unique numbers. So these would be the number of possibilities in each way that he can pick that exact digits in that order. So 1st, 2nd, 3rd, 4th, and 5th, 6 numbers. So by the fundamental counting principle, how many ways are there? Well, there's 50 options for the first number. Then once you've chosen that, there are 49 options for the second, 48 for the third, 47 for the fourth, 46 for the fifth, and 45 for the last number. So this turns out to be quite a very big number. All right, so if you put this into your calculator and you type that in there, so let's go 50 times 49 times 48 times 47 times 46 times 45. Okay, so when you first see that number on your calculator, this is scientific notation. So what does this mean? This 1.1441304 times 10 to the power 10. Well, that means that if you multiply this number by 10 to the power 10, you need to move the decimal here 10 places, okay, and then the rest will be zeros because of this 10. That's going to be 1, 2, 3, 4, 5, 6, 7. So after the 7th moving of the decimal place here, you have 3 spaces left over, and those are where those 3 zeros come from. So how do you read this number? Again, it's really important that you're able to read numbers like this, okay? So that's why I separated them in spaces of 3s, because how we read here, these will be the thousands, then the 100,000s, then the 100 millions, then the billions. So this would be 11,441,304,000 different ways. So you can see why the lotto, hardly anyone wins it. Look at the amount of options that you have to choose. Okay, that's quite large. And then if you want to know what's probability of the winning numbers, well, that is a completely different calculation, because then you would need to know how many ways can you choose the 6 correct digits in how many ways, and then divide that by the total number of ways. So this number that we've worked out here is the total number of ways we can choose 6 numbers. Doesn't mean that that is your odds of winning. It just means, so your odds in winning doesn't mean 1 in 11 million, no, because there's not just one single way to win that lotto. So what do I mean by that? So for example, let's say these were the winning numbers: 17, 34, 21, 15, 7, and 2. Okay, let's say for example those were the 6 winning numbers. Doesn't mean that you have to pick it in that exact order. No, you could have done 2 first, and then 17, then 15, then 34, then 7, and then what was the other number that I'm not seeing here? 17. No, we've done that one. 21. Okay, so there's actually what we say there are 1, 2, 3, 6 factorial ways that we can actually choose these 6 digits, but we'll see what that means when we look at factorial notation next. But okay, so again, this is counting without repetition. Essentially, it just means that once you've chosen an object, you cannot use that object again. Another classical example is, imagine you had 10 Easter eggs in a basket, and each of these Easter eggs are different, okay, from each other. Then if you pick out one, then the probability of picking out that one again is no longer there because we've already picked it out. We're not replacing that Easter egg, it's been taken out. So you can't count that egg again. It's been taken out, so there's no repetition there. Okay, so this is counting without repetition. I'll see you in the next one.